Hello! I made a new input manager add-on and I'm going to try to explain what it does, why it's good and why it's needed for some projects. A lot of people might know all the basics, but I'm still going to go over the level 0 for the people who are new to the engine. So first, what's an input manager? If you've just started with the construct, you might be familiar with behaviors. And usually behaviors like movement behaviors have a default control enabled. That way you can just drop a few sprites on screen and boom, you've got something that works where you can move around, etc. But pretty quickly you might find out that this is not enough most of the time to make a game. So the engine lets you disable the default controls and write your own controls. Usually that's done to add some more functionality to your game. Like for instance, this is a jump through platform, and by default the default controls don't allow you to jump through platforms, so instead you'd have something like this in your event sheet. That's pretty simple for events, just to let you move around, jump and drop through platforms. But then as your game grows, you might need to add even more stuff. For example, I made a little example with these little characters. All they do is give you a color to your player, like this. This is something that you might have in your game, and it still works with jump through, etc. And as your game grows, you're going to need to divide your event sheet into sub-event sheet. So for now I have this player movement that still have the same events as before, and a new skin system. It's super simple. It checks for when down is pressed, and it sets the skin if there's a sprite colliding with the player. But where this is problematic is this right here, because you've got the same input reference twice in your game at two different points, and that's a problem for the day you want to change your input controls. For instance, if you want to implement WASD controls or gamepad controls, etc., you're going to have to duplicate all of this code, and it gets messy very fast. And this is the exact reason I made the first input manager plugin, this one. That's very simple. Let's see how we could use it. So I'm going to create a new event sheet, rename it to inputs, add it to the first event sheet, and now all I have to do is copy paste this, and now I'm going to wire the inputs to a virtual input system, and now I have a super simple input system, and I can reference the new up, left, right and down inputs instead of the keyboard controls, like so. And now I can just take the down input, go into my skin system and turn it into a on input pressed, and it works the same way. And this is nice because I can now go back to the input board and add new input types. So for instance, if I want to add WASD controls, I can just do that. And now I just added WASD control everywhere in my game just by modifying this one event sheet. It's super simple. But now this system has its own limitations because it's really just the very basics. For one, it doesn't manage joysticks. It only manages digital inputs that can be either down or up. And it doesn't manage axes. Like for instance, on a controller, you might have these triggers at the back that give a different value depending on how much you press them, and you might want to use that in your game. And for now, the input system doesn't let you manage that, and you just don't have a multiplayer control because you might want to do local multiplayer with the same player code that's just managed by different inputs. For instance, what happens if I just duplicate my player, copy paste it, and add a new player ID variable. And this one will be player 2. Let's give him a different color by default. If I test the game right now, both players will be controlled with the same event sheet, and it's kind of problematic. Okay, so now let's say I want to have a second player. The issue with the current input manager system is it doesn't really differentiate between players, and the only way right now to make different controls would be to create new types of inputs. So like let's say up underscore player 0, up underscore player 1, etc. And it just creates a lot of duplication, because then the player movement code needs to also take these new words into account. It just creates way too much confusion in your code base just to add one single player. What the new input manager does is lets you manage what's called control schemes. A control scheme is going to be anything that's just a set of inputs that are wired to a set of words. In this case, up, left, down, right would be a control scheme. WASD would be a control scheme. So the equivalent to this with the new input manager would be something like this right here. And now what I've got is basically the same thing, just I've set a new player ID and scheme variables that I use right here. Player ID is a 0 based ID for your player, -1 represents every player, and the control scheme is the name of the scheme that's being used right now. So arrow keys for these keys and WASD for these keys. And now if I want to implement these new inputs into my player movement, all I can do is for each player and use the new plugin. And now I have a basically super simple code that's barely more complex, that does the same input management, but now manages two players. Like for instance, if I set the WASD to control player 1 and set input arrow keys to control player 2, like this, I can go back to my game. And now I have a super simple system where arrow keys control player 2 and WASD control player 1. But now there's another problem. Let's say I want to switch WASD and arrow keys from player 1 to player 2, and let's say I want both control schemes to control the same player, or I want to remap the control schemes at runtime. Currently that's not possible with the way we've done it. Instead I can use a wire system to set the player ID to a dynamic ID that I can set in runtime. So insert above, let's do an arithmetic, set value player ID to better input manager dot wire from and the name of the scheme. And now I can change where that wire goes. Right now both go to 0 because they haven't been set, so if we test right now we'll see that arrow keys and WASD control the same player, but it's very simple to change. All I need to do is on start of layout, map wire to player, so the name of the wire, WASD goes to player 0 and arrows go to player 1, arrow keys. And now we've got the same thing, but I can just change that whenever I want. Let's say when I press, I don't know, If I press P, it switches. This is for a test, just to show how the thing could be done. And now, if I press P, arrow keys control the other player. You can also wire both control schemes to the same player as we saw, and what happens is when a new control scheme is being used, it will disable the old one. So for instance, if I start going with the arrow keys and then press A, the WASD will take over. And now if I press a new key from the arrow keys, this one takes over. And you can only have one control scheme enabled per player, but they can all have different control schemes. If we see this more complex example, where I allow you to rewire the inputs at runtime, right now I have keyboard 1 that's this is arrow key keyboard 2, WASD for keyboard 1, and gamepad 1 and gamepad 2 for whatever is connected. So if I connect my gamepad, this, you'll see I can now control player 3. And if I wire the gamepad to player 1, I can now control player 1 with the gamepad. And I also can control player 1 with arrow keys. But the last control scheme that becomes red in this showcase takes over. So the other are disabled for that player. This is a behavior that I call auto switch control schemes, and you can enable it or disable it. It's very good for simple cases, but there are more complex setups where you want to have a bit more control over when the control scheme switches. So you can disable it, and you can even individually disable the auto switching behavior. How does the plugin decide when to auto switch? That's when you press an input down, specifically down, not up. And to prevent it from auto switching to that control scheme, you can check this box. And that's when a joystick goes out of its dead zone. So for example, I've got a gamepad implementation right now, where I just take the 2 axes from the gamepad and I wire them to its own control scheme. And if I press prevent auto switch, I will not be able to enable that control scheme automatically when I move the joystick out of its dead zone. Also, the input manager now has axes and joystick dead zones. By default they are at 0.2. You can change the default value in the plugin properties, and it's going to be used everywhere else in the system. But you can also set the specific dead zones manually. So for example, if I do dead zone, you can set specific axis and joystick dead zones, and you can set the default ones that will be used for every future axis and joystick created. An input and an axis and a joystick is only created the first time it's referenced, so either read or used. If you don't read, use, or reference any input axis or joystick, it will not be created by the plugin. So if you want to make sure everything is set up properly, just read the values of every input at the game startup, so you'll make sure everything is there. And now you've got the default control scheme. This is the control scheme that's assigned to the player if no other control scheme has been used, and if the auto switch control scheme is off. Because by default, when the control scheme is reference, so the same, written to, read, or anything else that just takes a control scheme ID, it will create it in the database. And if it is not the default control scheme, it will not enable it by default, and it will be enabled when it's used by the auto switch control scheme. But if that is disabled, you'll need to enable it manually after creating it, or just manage your input switching manually. If you want a control scheme to be enabled by default, you can use this. But the main issue is this is a default control scheme for every player, so every player will have that one control scheme enabled. That might not be the best, but hopefully it's pretty easy to just switch a given player's control scheme by using the set control scheme action. Just set the control scheme you want and the player you want to enable it to. And if you want, you can also use the wire system here, so self.wirefrom and the control scheme ID. That way you'll never enable a player's control scheme when the control scheme doesn't write to that player ID. And that should be everything. Let's see if I missed anything. So axis dead zones, axis value, so that's the same as a joystick but in one dimension. Joystick, control schemes, you can enable and disable auto switching at runtime. You can also simulate inputs up and down for digital inputs. All this will do is trigger the triggers, but this isn't really useful. It doesn't set the actual state, it just throws a trigger. And map wiring. For conditions, did I miss something? You've also got the basic is axis and joystick outside dead zone, and is any axis/joystick outside dead zone for a given player, and you have the same conditions for a player and a control scheme. For all of these conditions, you can set -1 as the player for to check for any player. And you can check if a control scheme is enabled, you can check if any button is down for a given player, and for a given player and control scheme, as always, -1 is for every player. And that's pretty much it. And then now you've got the triggers for on down, on up, on any down and on any up. And for the expressions, let's see if I missed anything. And expressions, battery input manager. You've got the get values. Get control scheme is the current control scheme of the player, so you're given a player ID. Last input and last player are used for the triggers. It will give you the last input name and last player ID to trigger that input. And the wirefrom that we've seen, and that's pretty much it. You've got raw and normal versions. The raw will ignore the dead zone, and normal will return 0 if the value is inside the dead zone. And another thing to take into account, the axis dead zone is a range, but the joystick dead zone is a circle. In some very specific cases, you might want the dead zone to be a square for the joystick. So in that case, you can just use two axes, one for X and one for Y, to get a square dead zone. That might be useful for very specific input configurations, but that's usually for advanced stuff. So you might already know how to do that. That should be everything. I'm very proud of what I've done. I spent the past week working on this for a game. And just so I could implement a lot of different control schemes. So for example, I'm going to show you how I've implemented it in a concrete game. And let's see, I've got, these are all the input schemes. Gamepad controls every gamepad. I've got a for loop for every gamepad ID. I just have 0 and 1 for now, but I can go up to whatever number I want. And all of these just map the inputs to a given digital input. And I have a fallback for joysticks. So for example, I have the main joystick, this one, or the movement joystick, I don't know. The movement joystick is the main one that's going to be used, but if it isn't being used, it might use the second joystick, and if it isn't being used either, it's going to look at the D-pad for the control. And that's all made using the input manager. And I just set the values here as digital and joystick values. So I have joystick 0, joystick 1, and then all the D-pad action. And now I have the code that sets all of this and checks to set the final real joystick that's being used in the game. And I do the same thing for other input controls. For example, for touch, I have a smart joystick plugin that gives me a direction and a range for my plugin for my joystick. For mouse, I have a different control scheme where the player will move towards the mouse. So technically, it's still a joystick but centered on the player, and it's fairly simple. And I also have a special click event that forces the control scheme to enable when I click the screen. And I have the arrow keys and WASD with ZQSD for European keyboards. And all of this gives me a pretty complete input control where I can control with my mouse, I can control with these touch controls that I can't use because they're only using touch. I can control with arrow keys, with WASD, and with a gamepad if I wanted to use a gamepad. That's pretty much it. This is everything there is to know. It's a pretty long video. I'm going to try to cut a lot of it. I think it's going to be about 20 minutes in the end. Thank you for listening. Bye bye.